Hey everybody, I'm Marcus Hazelwood, and welcome to Clear Haze Exchange. I'm an energy engineer with over 15 years of experience in sustainability and energy efficiency consulting. Many find these topics a little complex, so I created Clear Haze Exchange to help provide clear, actionable insight, clearing the haze, so to speak. We'll cover plenty of topics under the umbrella of energy efficiency and sustainability. Let's get into today's conversation. Welcome to Clear Haze Exchange, where we're focusing on revealing the invisible system shaping sustainability, performance, and long term value. Today's guest is Vaughn Horn. Vaughn and I met at the International Institute for Sustainable Laboratories, I2SL, and he was a speaker at that conference, and he talked on the topic of mass timber. So I'm looking forward to this conversation. Vaughn is a licensed architect and senior project manager at an architectural firm, HGA, which specializes in science, technology, and higher education buildings. He holds a Doctor of Design from Harvard University Graduate School of Design, where his research focused on long-term social, structural, and policy forces shaping the built environment. Vaughn brings a rare blend of design leadership, academic research, and real world project delivery, including deep expertise in mass timber systems and their implications for performance, carbon, and constructability. Vaughn, welcome to the show.
Thank you. Appreciate it.
Yeah, so we met on a rooftop
Soiree.
yeah, sorry.
Yeah, it was one of those events. There was probably two or three different companies, different engineering firms hosting different events
Yeah,
on that night of I2SL.
yeah, yeah. It was a lot of good conversation. We had some great conversation and about experience that you have, and
Yeah,
but could you talk a little bit about what you do and mass timber, how you got into that?
yeah, sure. So, as an architect, my specialty has varied over my career. This is the first instance in my career where mass timber has become part of the practice. I think because we've reached a time where the construction technology and changes in the code have allowed us to be more flexible in how we use it to make hybrid systems, to make high rises. What I presented about at I2SL in Dallas this past fall was about tuning a high rise laboratory for performance using a mass timber hybrid system. And I think um, within my firm, I'm part of a knowledge community where we express and ideate and research on different mass timber technologies. A combination of our internal team of architects and engineers have had a pretty good time with finding out the practical applications, but also barriers to entry and things like that. A lot of it, trying to apply it to as many building types as we can within our portfolio has been the challenge, but we've had some successes.
Would you say if you were to describe in short what mass timber is?
Mhm. Sure. It's a wood frame construction emphasis that uses different types of wood in an environment that's suitable for multiple and varied uses. The idea is an old one. Type 5 stick built construction is centuries old and at least more than a century old, if you will. But the use of heavy timber, which was the old Type 4 in the International Building Code, that has had some flexibility in recent code changes where mass timber, the idea of having a timber frame building for the columns, beams, bearing walls, or not having bearing walls, and having some other sort of hybrid system have become more practically applicable these days. And so that's where I am now. One of my first projects as an architect over 20 something years ago, 25 years ago, when I was just sort of an independent subcontractor in my young 20s. That was a stick frame building. That was Type 5 construction. So growing up in the California area, just in Los Angeles, just understanding the importance of Type 5 and especially with earthquake loads and resistance and things like that, had always been an interest of mine to explore further. Although I'm proficient in steel and concrete, I think we're at a critical juncture where mass timber, especially the use of glue laminated structural members, is key, but then also understanding the challenges, the limitations, and the costs involved.
So from your perspective, why would you say mass timber has gained so much momentum, especially in higher education and research environments?
Yeah, I think it's two things happening simultaneously. There's architects who are promoting the use of mass timber, not only for its aesthetics, but for its lifespan, but being something that can be demounted and used sustainably in the future. So when you look at life cycle and a life cycle analysis, wood has proven to be fundamentally superior to many of our conventional framing techniques, if you will, for a building. On the other hand, also pushing this effort are clients who have dialed in to not only the aesthetic appeal of having exposed wood on the interior and sometimes the exterior of their buildings, but it's also from a sustainability standpoint, the whole carbon story, the carbon pact that some jurisdictions where these buildings are, the leaders in those at the municipal level and even at the state level have bought in to the use of mass timber, and therefore the clients have also gotten on board as well. So you're finding that the combination of architects sort of leading the story, but having more informed clients who come in with a certain amount of knowledge about mass timber and its uses helps to further the conversation and facilitate where we are today.
Yeah, yeah, it makes sense. So would you say that this movement is kind of a balance driven between the carbon impact it has or the design culture, policy, or institutional? Would you say it's a mix of all these or is one kind of leading more so than the other?
That's a good question. The building type would help us understand what's the lead dog, if you will, if we were to treat it like the Iditarod or some kind of sled dogs in a row, where you'd have the lead dogs in the front. What are the one or two things that are most critical in any given setting? It depends on the setting, right? In my experience, especially with the high rise application of mass timber and then applying it to a laboratory environment, it's using it as a recruiting tool, combining it with things like a high performing building envelope that is appealing. And that's what's shaping the moment. I think when you see that opportunity to have a high glaze system, a large amount of area on the building envelope where light can come in through transparent and translucent, that part is exciting to people. It's more than trendy. It's actually quite significant in terms of how we look at and treat energy use in our buildings. If we put energy use as the lead dog, right next to it would be its ability to attract and recruit people. So if you're drawing people in, you're also thinking simultaneously about energy. And those two would be at the forefront. And the energy story, you know, segues right into the carbon pact that people have, the promise to follow these guidelines and things like that. For the recruitment factor, or sort of energy or attracting people, there's something about being in an environment surrounded by exposed wood that people really like. The biophilic part of this is very high. As you get into the practical applications, sometimes the position of those lead dogs might shift, but the energy goal stays at the forefront, and you might swap out the attractiveness of it with something else. But energy at the forefront gets you pretty far in any room across the country if you're talking about mass timber.
Especially with the related cost, because of course being a driver, energy impact rolls into cost, just as you mentioned the carbon. It kind of fixes both. If you're fixing the energy challenge, you're fixing cost and you're fixing carbon in a way because of that carbon
Right.
capture aspect.
Yeah. And one part of the fixing of the cost is understanding the premiums because cost savings isn't necessarily part of the game. It's understanding and reconciling the premiums and knowing where things are going to cost more but benefit you later. So do you spend more money now up front and then the first couple of years of operating a building so that it can pay off down the road? And that, that's the calibration of costs, I would say, is probably in that second tier right behind those two lead dogs, if you will, to keep that analogy going.
But the focus on long term benefit.
Right. Yeah.
Yeah,
Yeah.
that's good.
You're definitely going to spend some money if you're talking any kind of combination of mass timber, just compared to how we've done steel buildings and made them relatively cheap. Of course, a fully stick built for a type 5 building, wood frame, low rise, is going to be about half the cost of a composite steel building. When you get into like high rise applications with beefier members, and you start making large spans and things like that, where you have to introduce different types of wood members, including glue laminated members that are bigger, wider, deeper, can span longer, it becomes more expensive than steel. And um, that part is important to understand in that cost calibration.
Yeah, that's good. So that kind of segues into what I want to talk about concerning hidden systems behind mass timber related
Sure.
to decision making,
Mhm.
because that is a heavy piece. Understanding where decisions impact benefit to the client, the owner, but because there's a lot of intricate systems involved. So, what systems would you say owners might underestimate when they commit to mass timber early in a project?
Mhm. The module, if unless they're dialed in for say housing, you understand the module. You know that um, your one bedroom apartment is roughly the same size no matter how you slice it up and where you would place it. So you would understand this working backward from the type of building that you have with the type of structural span that you need, and uh, essentially trying to keep as much as the occupiable space in whatever building type you have as free of columns and obstructions such as shear walls that hold the building up, but also have a lateral support built into their function. So clients who understand the math, if you will, of the geometry of that's involved with the spaces um, that make up their building come in a little bit more well equipped. There's no shock to like, oh, you couldn't achieve it with mass timber, or you had to do this in order to achieve it with mass timber. And that's the important part is that clients do their research, that they understand that if you're looking at an educational facility, your classroom buildings could be framed in mass timber. Most certainly, you understand the module that's involved with that, like the width to depth ratios. They matter. They matter in a retail environment. They matter in a classroom. They matter for apartments and things like that. They matter in a lab. So you start with that, and then you can understand which mass timber system makes the most sense. Um, for example, so if you have a client who is a multifamily housing developer, they're likely would lean toward having something that might be cross-laminated timber with a bearing wall support system that's also made of wood. So with cross-laminated timbers members, also keeping them exposed in that environment has the biophilic effect, but it also achieves a structural effect and meets the kind of structural grid, the structural module. I would advise any client not to fall in love with any one combination that they might have seen in the application of mass timber. Go in open minded, knowing that your building can have timber elements in it, but it might be morphed or hybridized so that you can bring in steel where needed, bring in concrete where needed. Um, but if you're a housing developer with multifamily housing in your portfolio, you can do CLT with stick frame bearing walls. People are doing it now, no problem. You can do that rapidly. Has a high amount of embodied carbon, but it limits your flexibility. You can't go and move those shear walls, those bearing walls. But there's other limitations for fire ratings for switching those kinds of classes, residential to business, etc.
Yeah, and that segues into the other question I have around that, which the first thought when you think mass timber is, well, how is fire protection systems going to impact, or how does code
Hmm.
regulate the fire protection systems? And then also acoustics, like you mentioned some of these, you touched heavily on the structural side, but what
Hmm.
about the systems like fire protection,
Hmm.
vibration, acoustics, and MEP, the mechanical, electrical, plumbing systems? How do they how are they impacted? Do they struggle, or
Hmm.
how are they influenced?
Right. Working backward from MEP, the struggle is trying to, trying to do anything that's not forecasting how an MEP system integrates with any mass timber frame that you're suggesting. So in other words, at the very beginning of a project, you need to have an idea how ducts are routed. If you're going to have HVAC, you're going to have piping for plumbing that has to go horizontal in the horizontal direction and vertically. So understanding that, the pain points will come with trying to figure that out later. And I would recommend that clients and designers understand how to frame a core in a building and where to place them. Things that you want to avoid with mass timber, especially with MEP, and that's beam penetrations. Beam penetrations weaken your structure. They're allowable, but you have to understand the calculus behind it. You have to understand the beam profile. The fire rating consideration is huge, especially for a lab application. But what the code has done, recent code updates to the IBC has given us three subcategories for type 4 construction that are conducive to a mass timber frame. Type 4A, type 4B, and type 4C. Now, some engineers and fire protection and code specialists might contend that a mass timber building could be any type of construction type, and I would push back on that and say, well we should stick with what's given to us because there's the non-combustible part of type 1 and type 2 cannot be met with any kind of mass timber combination. Non-combustible is assumed to be steel and concrete, so you can't really call a mass timber frame a type 1 building, type 1A. You can't really go there. So I would push back on anyone that would say that, like, let's talk that through. But what you can say for fire resistance is that in type 4 A, B, and C, you have your height limits, but you also have the fire resistance that's needed in between the floors for each level. So the code gives us some flexibility, but it gives us some directives. The directive is, and you can combine the knowledge of the IFC, the International Fire Code, and the IBC, International Building Code. It all just depends on the hazard level and the building type. But how char layers work for those at home who are not familiar with that might sound like jargon, but it actually kind of makes sense. Like when you think of fire and wood, it chars once it comes into contact with each other. The fire wins each time. But as it winnows, becomes more to a charred consistency or texture, it becomes unusable. And the part that's underneath that's supposed to be supporting the building from falling, if you will, keeping its structural integrity, that is still protected. So the building will still stand up. You're not talking about having an instance where a building would fall down. I mean, it might fall down in a calamitous fire, but the code is trying to protect the public by saying make your members robust enough, and then build in this char layer so that you have that protection in place to keep the structural integrity of the building intact, while this particular set of members in the building is exposed to uh, a calamitous fire for 2 hours, which it would be rare that it's just fully exposed without any kind of fire suppression system. Nonetheless, you need that char layer. So the char layer has to be considered in your calculation, has to be considered in your selection of your structural system and your entire approach. Um, and then also what you're building in its context.
Yeah.
But yeah, that's how you would go about the fire resistance rating is looking at the building type, and what the code would require under that particular building type and
So that
occupancy.
So that makes me start thinking about schedule and procurement, the supply chain, because you're talking about what all has to be done with these structures that are replacing essentially steel structures. But now you have to layer up this structure that's supporting your building. Very important, considering fire, considering weight, all these calculations that you mentioned. So where does scheduling and procurement and supply chain become drivers of building this type of structure rather than sustainability intent? I
Hmm.
know it's something they have to consider, but how does that come into
Yeah.
play?
Well, that's a good question. It's also, pretty layered because supply chain is sustainability. It's a core function within LEED. The regional sourcing of materials is something that people looking at buildings through a sustainability lens must keep in mind. One thing to consider is if you're in, say, the Midwest, you actually are in a good position to where you could procure um, the cross-laminated timbers or dowel laminated timbers or any of the types of advancements made for timber, um, glulam or otherwise. It's relatively easy to get it in the Midwest these days. If you're trying, say, in Hawaii, where it might be harder to have things shipped to you, that's part of the supply chain. That's where you lose on the carbon footprint side of your sustainability. Are you bringing in the types of trees to like a tropical environment or something distant, like out in the middle of the ocean? Um, is that causing you more harm than good? Maybe you'd want to consider a different building type than a mass timber, or look at something more indigenous, more friendly to the environment. My advice would be to look at the regional suppliers and encourage your contractor to or even your architect to have a relationship or strike up conversations with the 2 to 3 to 4 suppliers, the manufacturers that can build this at scale. And the sustainability would come in a couple of ways. One would be in the module and making the members similar sizes. So in terms of schedule, if you have your module set, you're not doing all these sort of custom cuts, especially in the field. You want as much of it to come out of the shop, if you will. By the time it lands in the field, um, the subcontractors in the field would be more um, in the realm of doing assembly than fabrication. So if you look at schedule, nail down the module, keep things as regular as possible so that it can all be done 90% of it, 80% of it, whatever percent is high enough for the client's appetite. Have as much of that done offsite and brought to the site, constructed there. There's a treehouse project that was built by Studio Gang with Gene Gang, the architect, here in the Boston area in Allston, Mass, not too far from Harvard's business school campus. And it's a beautiful building, mass timber, framed, but it's unconventional in terms of how it looks. It has sort of an amorphous shape to form to it. And you can look at it and tell that the pieces that were built in the shop, had to be modularized but still brought to the field and cut to shape to fit in place. It's hard to panelize some of these things, make it into panels and something very efficient that can be brought. You have to think of the logistics too with the schedule and the sustainability focus of this. Are you blowing your carbon budget by making this thing impossible to get to the site? You would lose on the supply chain side if you don't do your research on who's doing specific types of mass timber framing. Like Smart Lam has very unique ways as a company that they're orienting the ply within their CLT. So each layer can be offset in a way, and they figured it out that it can serve different purposes, could even accept the kinds of penetrations you would need for ductwork and things like that. But they're leaning in the proprietary direction. Not everyone is doing it that way. So you'd have to know kind of going in, like, you'd almost be limiting yourself in a good way by saying like, well, we need to go with Smart Lamb for this. The trade-off would be like, if everyone is saying that, you're not going to be able to get your stuff when you think you need it. So you have to build in the lead times and get someone from the in pre-construction as to advise your clients.
So would you say that designers have that responsibility to provide pushback for your clients and also building owners, but also when institutions have the kind of more enthusiasm about the opportunity for carbon offsets? What responsibilities do you have, and how do you go about providing a reasonable amount of
Mhm.
knowledge um,
Yeah.
without kind of knocking the enthusiasm? The intent is great, but the operational and reality piece.
Yeah, you can. Great thing with in architecture, we have at our disposal the ability to visualize data. Data will win the day in terms of pushing any particular design over the finish line, especially if you're marrying it to any idea of mass timber. So if you have an enthusiast on the client side, and they're wanting to see the offsets, bring to their attention what we're really talking about with embodied carbon. When you're bringing in embodied carbon and you're looking at the life cycle of the material, wood by its nature absorbs carbon, and it would take complete incineration to release that carbon back into the atmosphere. Like cutting wood is not going to release its carbon. It's the burning of the wood down to its like molecular level that you start to say like, man, we lost all the carbon benefits. So that's one thing to consider is the data involved with taking, say, a baseline. Architects should take a baseline building frame, call it steel, say an all steel building compared to any combination of mass timber elements. Your important story is the data up front of what you understand to be the building footprint, the complexities of the building, comparing it to a baseline. Now, you might unintentionally sell the client on a steel building, and that's okay. But if they're armed with the information, you're fundamentally doing what architects are supposed to do, which was educate the client, or at least we were trained to educate the client. These days, it's more symbiotic, is more reflexive. I think one thing to prep a client about is the carbon story is not complete with embodied carbon. It's not complete if you're just looking at what it would take to source this raw material and construct it and look at its life cycle. You got to look at the operation of a building too, the carbon that comes with just turning lights on and off and running all your HVAC systems. That's also part of the carbon story that lends itself well to a true carbon pact.
Yeah. Oh, that's good. This has been really informative. Appreciate the information that that provides really good perspective, and I'm learning a lot of. But to kind of close out this discussion, um, if decision makers were to make one mindset shift tomorrow around mass timber structures, what would most improve long term sustainability outcomes?
That's a good question. It's the continued support from above, I think, outside of the walls. I talk about the policy level. the clients aren't operating in a vacuum, and I'm hopeful that the ones that at least you're encountering understand that. If you are a client that's a developer that's in, say, in Massachusetts, we have what are called green communities that were early adopters of like something like the specialized code. And the specialized code was all about energy use. If you're in that environment, you know that you have to keep pace. It's required by code. Code is saying that you have to do it if you're wanting to build. So my advice would be like, if a client doesn't feel that way, find a different jurisdiction. So like set up shop somewhere where the policies aren't as restrictive. Like on the project that we presented at I2SL, we embraced the limitations of the code. We didn't find that it was a deterrent. It was actually helping the design because you wanted to achieve something that had, if they have a vision, the client has a vision for things with large windows and things like that, and you still want to have mass timber, it comes at a cost. It comes with trade-offs, but it also comes with being very mindful of the stringency of the code. Now, a forward-thinking client with a lot of resources and a lot of sway could change the conversation a little bit and help convert a community into something that's a little more green thinking. The green thinking doesn't have to be unilateral. It can be, well, if mass timber isn't in the cards for this project, what is that could help us with our carbon footprint? Is it in the sourcing of the raw materials used in the interior of a building? We're also looking at like other things like off-gassing and things like that that contribute to the environmental detriments, if you will, or environmental quality when in an enclosed environment. I would say we should also, as architects, avoid clients that feel like they don't have to comply with that within their community. That's just not playing the game right. You don't want to go into it not seeing eye to eye on that kind of stuff. It's fundamentally important, but they need to know their environment, their community. If they're in one of these green communities, they got to know the code, and it's our responsibility to explain to them so that they can be as informed as they can.
Good. That's good. Well, really appreciate your insight. This has been a very, very valuable conversation around the topic of mass timber. You've certainly cleared the haze around this topic and the intricate details that are behind the scenes that people really don't see and understand. That's why you bring on experts like yourself to understand things more in depth. That pretty picture of, oh, we're going to reduce this much over that baseline in carbon emissions, that sounds good, but let's look at the practical and what is actually achievable. And then talking about the schedules, considering all the impacts, understanding that putting up these wood structures isn't just in putting it up. There's a lot of, weather rated, fire rated walls, impacts, the MEP systems, a lot of details around this to make this work. But from an owner's perspective, understanding these kind of high level topics that you could run into going into it more informed is better. So I really appreciate this conversation, Vaughn. Thanks for taking the time to break this down. It was really helpful, and hopefully, it's helpful for the audience. As we depart, any parting thoughts?
No, mine, yeah, in our sidebars have been like, I highly encourage you to bring this show on the road and come to the NOMA conference, National Organization of Minority Architects. It'll be in October of this year in Miami. I could see you there on the convention floor with your sign lit up or some sort of people. I tell you, once people find out and have a platform like this to discuss, there's much to discuss on the technical level and culturally as well. But also would be remiss if I didn't get a shout out in my from you're giving shout out to my educational background. My Harvard doctorate was like the end of my educational story, but it began at the University of Southern California in LA, where I got my Bachelor of Architecture. So I shout out to my teachers who instilled into me the importance of sustainability. Mark Schiller, especially, really stood out as one of the best. And then during my master's degree at Syracuse, I have to give them a shout out as well. So it was part of an educational journey that where sustainability and thinking about cities themselves in a green and responsible way uh, had its roots back in the mid '90s when I was an undergrad. So I just wanted to. I'd be remiss if I didn't give them a shout out and say, thanks for helping me see the picture a bit more clear, and my approach to being an architect.
I appreciate it, and I'll certainly look forward to that and reconnecting. Maybe we'll reconnect there on a
Yeah, and
podcast, sitting
that's
sitting out
right.
there on the
I'd,
floor.
I'd be
And
happy to sit there with you and we'll
yeah,
try to get people to come and talk about various topics. But
yeah, because it is important, and that's where my passion comes from. Is that ability to allow people to see, just simply see, and be educated on some of these topics. Just simply talking about the firewall. It's like, wow, there's a lot more that
yeah,
goes into what we see,
oh,
and I
absolutely,
think it's very valuable for people to be able to have the opportunity, even if it's in passing. So, however we can get out the value of educating and being informed. You can't put a price on it. So.
totally agree.
Well, thanks again, Vaughn, for joining us, and until next time, we'll see you on the next show.
Sounds good. Much appreciated to you for having me. It's been a pleasure and an honor. Thank you. Thanks for listening to Clear Haze Exchange. New episodes drop every 2 weeks. You can catch Clear Haze Exchange on Apple Podcasts, Spotify, Pandora, iHeartRadio, and more. Let's clear the haze about sustainability and energy efficiency together. Subscribe now and join the conversation.